In example 1, we need to evaluate the functions when x is equal to 2. So this is function notation. Note that x is 2, so on the left-hand side, we're going to replace x with the 2. On the right-hand side, we do the same thing. It's important that you understand that f at 2 means the output, and it's a single value. F at 2, or f of 2, means the output when the input is 2. And here our input is 2. So we're going to do a little bit of order of operations here. 3 times 2 is 6, minus 18. And 6 minus 18 is negative 12. And remember that that's f at 2. Some students will try now to divide by 2 here because they see this as multiplication. However, this is a new notation, it's function notation, and this does not mean to multiply. This means function f. It's an identifier for which function you need to look at. If you look at the above row, we've got f, g, and h. And so if you say function h, you wouldn't look at this one or this one, you would look right to function h. It's simply an identifier. It does not mean to multiply the h and the x, the g and the x, or the f and the x together. That's not what it means. It just identifies which function it is. So our answer here would be the output is negative 12 when the input is 2. Those are good words to use when you're talking about functions. So we'll do the same thing here for g. We'll do g of 2. And what we need to do then is just substitute in 2 for x. So now we'll do a little order of operations. Our eyes are going to look right here to these parentheses. 2 minus 7 is negative 5. Then we've got 14 plus 10 here. And we're going to have g at 2 then being equal to 24. Once again, when the input is 2, the output, g of 2, is 24. H of x, we're going to substitute 2 in for x. All of these we want to evaluate when h is 2. So we've got negative 5 over 4 times 2 minus 6. If we do our order of operations, we're going to do this multiplication first. Negative 5 over 4 times 2 is the same as negative 5 over 4 times 2 over 1. So we can utilize our cross cancellation here. That's a 1, that's a 2. So we've got negative 5 over 2 minus 6. Now when we add fractions together, we need to make sure we have a common denominator. So if I think about this negative 6 as over 1, I want the denominator to be 2, but I'm not allowed to multiply a fraction by anything other than 1. So I need to multiply the numerator by 2 now. So that'll be negative 12 over 2. Remember, multiplying fractions, multiply the numerators together and the denominators. I have 2 negative values, so I'm going to wind up with a larger negative value. Negative 5 minus 12 is negative 17. And the common denominator is 2. You're often going to see that negative sign written right to the left of the horizontal fraction bar. This negative sign could belong in the numerator or the denominator, but not both at the same time. Then you'd have a negative divided by a negative, which would be a positive. And this value is definitely negative. And we could list here h of 2 is equal to negative 17 over 2. In algebra, this improper fraction is better to use. If you're graphing, though, you might want to change that to a mixed number or a decimal. Or if you're relating something to someone in real life, like how many feet of tape you need, or fencing, or inches of string, or what have you, most times you would state that as a decimal or a mixed number.